Muito boa noite a todos e todas. Estamos aqui para a primeira Tech Tuesday do ano de 2023, com o tema Conductor Integrity Issues and Solutions, que vai ser apresentada pelo Chris e moderada pelo nosso diretor de Relações Internacionais, Pierre. Eu estou acompanhado aqui do nosso diretor Sérgio Cavalcante, nosso diretor de eventos, e é ele que estará encarregado de organizar as próximas Tech Tuesday. Então, no caso que você tenha alguma apresentação que se enquadre nos critérios da SPE Brasil, ou seja, uma apresentação de interesse geral, sem comercialismo, né, que traga conhecimento para a indústria, entre em contato com o Sérgio, ele vai falar o contato dele aí, e para a gente compor o nosso calendário de 2023. Né? Eu acho que neste ano nós não teremos terças-feiras toda semana, terças técnicas toda semana, porque nós temos uma grande quantidade de eventos, como tivemos no ano passado, e eu vou passar, então, um pouquinho dessas coisas, e a gente vai ver, desses eventos, a gente vai ver exatamente o quão sobrecarregado está. Deixa eu passar a palavra para o Sérgio, para ele se apresentar rapidamente e falar, então, como as pessoas podem achá-lo para propor temas para as próximas terças técnicas. Sérgio? Está no mudo.
Perfeito, Pedroso. Muito obrigado aí. Boa noite a todos, bem-vindos aí à primeira Tech Tuesday, né, do ano. Agradeço aí, Pedroso, pela apresentação. Tá? Meu nome é Sérgio Cavalcante. Eu sou consultor sênior na Petrobras, trabalho na área de reservatórios e assumi esse desafio aí, né, junto com o Pedroso, de estar nessa gestão da SPE como diretor de eventos. Né? Então, eu convido todos vocês que têm trabalhos técnicos, né, trabalhos que adicione conhecimento à indústria, né, compartilhamento de conhecimento, estudos de caso, que entrem em contato comigo. Né? Eu vou colocar meu LinkedIn aqui no chat, tá, para que vocês todos tenham acesso, e aí a gente pode agendar, colocar vocês na programação, tá bom? Divulgar o trabalho de vocês, né, e contribuir com a nossa indústria, tá bom? Eu queria agradecer aí ao Pierre e ao Cris, né, e retorno a palavra para o Pedroso. Obrigado aí, Pedroso.
Obrigado, Sérgio. Eu gostaria de agradecer ao Sérgio pela organização dessa primeira Tech Tuesday e, obviamente, também ao Pierre e ao Chris pela disposição em estar aqui apresentando. E também ao Eduardo, que está no backstage, eu sempre brinco, né? É a pessoa que faz essa engrenagem girar. Muito obrigado, Eduardo, pela participação. Obrigado, Pierre e Chris. Como sempre, a gente vai falar dos eventos da Seção Brasil e nossos associados, né? E como no ano passado, a gente tem muitas atividades. Então, a gente começa aí com os eventos que serão organizados em conjunto com a Seção Macaé. Nós temos 4 eventos. Em maio, a gente começa com um workshop de campos maduros, que vai ser realizado presencialmente em Macaé. Depois, a gente passa para o segundo semestre com o workshop de segurança operacional de postos, também realizado em Macaé. Ambos já estão aí com as páginas, né? Pode acessar pela página da Seção Macaé, acessa esses 2 workshops. Depois, o já consagrado FPSO Simpósio, que será em 12 e 13 de setembro no Hotel Flórida, e 22 a 23 de novembro, o Subsea Simpósio, em sua 3ª edição, que também será no Hotel Flórida. Pode passar? Então, esses eventos que eu falei são os que serão realizados em conjunto com a Seção Macaé. Agora, os eventos que serão realizados solo pela Seção Brasil, 20 a 22 de junho, o evento de sustentabilidade, o simpósio de sustentabilidade, né, os desafios para o futuro, será realizado no Rio de Janeiro, local ainda por definir. 27 a 29 de junho, SPE Brasil Decommissioning Symposium, também será realizado no Rio de Janeiro, então, final de junho, possivelmente no Hotel Guanabara. 2 a 4 de agosto, nós teremos o Integrity Management Systems, o Holistic Approach, realizado também aqui no Rio de Janeiro, e 22 a 23 de agosto estaremos retomando a Brasil Onshore, que deverá ser realizado em Maceió, 22 a 23 de agosto, local a definir, mas a cidade já está praticamente fechada. Então, depois de perto aí de 8 anos, nós estamos retomando a realização da Brasil Onshore. Agora, um pouquinho mais sobre cada evento, o nosso dia a dia, pode passar? Então, estamos com o programa de mentoria da Diretoria de Diversidade e Inclusão do Comitê WIN, Women in Energy. O programa de mentoria está aberto, as inscrições estão abertas até, então, 6 de março, já começou. Então, se você quer participar do programa de mentoria feminina, né, se é uma mulher bem-sucedida ou em início de carreira, mas que queira transmitir conhecimento, se inscreva, e se você é uma estudante ou uma profissional no início de carreira que gostaria de ser mentorada, se inscreva no programa também. Temos oportunidade para todas as mulheres neste programa tão importante que é incentivar a diversidade de gênero na nossa indústria. Pode passar? No dia 27 de fevereiro, nós teremos a 15ª edição do Digitalks, em memória da Caroline Casarim, que passou recentemente aí, falando de modelos digitais virtuais de afloramento, contribuições para a geologia de petróleo, que vai ser moderada pelo Farid e com o Luiz Gonzaga da Silveira como palestrante. Então, 27 de fevereiro, às 18 horas. Pode passar? Também está aberto, né, eu estou colocando mais ou menos em ordem cronológica, e está aberto até o dia 1º de março as nomeações para o Regional Award. Qualquer associado do SPE pode nomear alguém e pode ser nomeado. Então, entra na página da SPE.org, Award, e verifica lá as condições e se você gostaria de indicar alguém para o prêmio regional. Regional é América do Sul e Caribe. Pode passar? Também estamos com o Call for Papers da OTC Brasil, aberto até 7 de março. É uma ótima oportunidade de você apresentar seu trabalho num evento internacional, extremamente é um evento importante e muito bem visto mundo afora, OTC Brasil 2023. Então, a submissão de abstract está aberta até o dia 7 de março. Pode passar? Agora, e no dia 9 de março, nós teremos a premiação de 2022 da Excelência Técnica e Profissional da Indústria Nacional. Eu estava dizendo que 2022 foi um ano tão intenso para nós da SPE Brasil em termos de atividade, que ele só está acabando agora, neste ano, né? Então, a gente estava até ontem resolvendo ainda algumas das pendências que ficaram de 2022, e então agora, vamos encerrar no dia 9 de março o ano de 2022 para começar o ano de 2023, então, com a premiação nacional da Excelência Técnica e Profissional. Normalmente, ele é feito em dezembro do mesmo ano, mas, como eu disse, 2022 foi um ano tão cheio de atividades, como vocês estão vendo, será 2023 também, que a gente só está terminando o ano agora em março. Se bem que para o Brasil não tem muito problema, né? Que como só começa depois do Carnaval, então a gente está terminando depois do Carnaval e começa 2023. Pode passar. Estamos com o Student Paper Contest aberto também para, né, estudantes, então, são 2 eventos de estudante agora que eu vou falar. O prazo para submissão dos abstracts para participar do Paper Contest da América Latina e Caribe, que será em Trinidad e Tobago em junho. Então, o prazo é até 13 de março, então, basicamente daqui a um mês. Pode passar. Para o dia 1º de abril, nós teremos o Petro Games, tá? Então guarde na sua agenda, já se a sua empresa tem interesse em participar, já estamos com o patrocinador Platina, a April, e será então em 1º de abril, Petro Games, interessantíssimo, e como todos sabem, ele é classificatório para o Petrobol regional. Tá? Então, se você tem uma equipe, se inscreva. Pode passar. Então, falando só mais um pouquinho, né, o nosso primeiro grande evento é o workshop de Campos Maduros, que será de 30 a 31 de maio, na cidade de Macaé, no Royal Atlântica. Falando, então, já estamos com o patrocínio da Petrobras praticamente fechado, o comitê técnico composto e já várias das sessões prontas. Dentro de mais ou menos um mês, a gente vai estar com esse evento totalmente pronto para a execução. Se você quiser mais detalhes, visite a página da seção Macaé, Workshop Campos Maduros, e veja mais detalhes. Inclusive, está aberto também para patrocínios. Pode passar? Então, sem mais delongas, let's switch to English now. So, let's go to the theme for this Tech Tuesday, Conductor Integrity Issues and Solutions, that will be delivered by Chris Tierney. And I would like to introduce Pierre Vincent next, which will be the moderator. So, Pierre Vincent has been an active SPE member for most of his career in Europe, Americas, Asia, and Africa. He holds engineering degrees in mechanical engineering, petroleum engineering, and business administration. And his current skills are focused on well construction and delivery, integrity, and plug and abandon. Thank you, Pierre, for coming, and the stage is yours.
Thanks for the
Muito bom
kind.
evento a todos. Pode passar? Muito bom evento a todos. E eu gostaria de agradecer aos nossos patrocinadores, a Total Energy, a Enalta e a Perril. Bom evento a todos. Very good presentation. Thank you, Pierre.
Thank you, Carlos. Obrigado. Boa tarde a todos. Thanks for the opportunity to present. It will be the first Tech Tuesday of the year, so we look forward to that. And we thought we would bring somebody with experience to share from outside of Brazil. So I'll switch to the short introduction to Chris. Chris is backstage, and he will be giving us that. So introduction, after more than 20 years in the subsea industry, Chris Tierney has been developing processes, methods, equipment, and teams around the subsea intervention requirements, particularly with regards to aging assets. For most of the last 8 years, he's been involved in a number of projects globally, which got him involved in a number of well integrity projects with a particular focus on conductor management and integrity requirements. Involved in the design and delivery of platform deployed subsea cleaning, inspection, and repair equipment, Chris has worked with a number of clients to improve or implement new risk-based inspection programs and solutions, ensuring safe late life for wells. So Chris, welcome to the stage. I'll let you manage the presentation. You can ask, other people can ask questions, and we might be taking the good questions, relevant ones, as we go. Over to you, Chris.
Obrigado, Pierre Edward, and boa noite, everyone. Thank you for the opportunity to come and present this evening. I have quite a sizable presentation here, so please don't panic. I'm not going to be sitting reading to everyone and trying to just go through slide by slide. The SPE team will make this available, and obviously my contact details should anybody want to discuss any of this any further, and you can get me through SPE also, of course. So yeah, as guys were just mentioning, I've been focusing on particularly conductors. Obviously caissons we get very good at back in the 90s when they started falling off some of our older assets. But the conductors became quite a new phenomenon over the last 7-8 years when we started developing issues that probably weren't foreseen, and weren't actually falling into anyone's risk-based inspection programs, as was just mentioned. The conductor itself there is an environmental protection more than anything else. Well load sharing, it is, although it's a structural component, it typically doesn't fall within the structural team's integrity management system, and actually has been viewed as forming part of the well, despite it not being a pressure retaining part of the well. So it's kind of been getting missed and falling in the gaps, and despite them having quite a robust design life, when they went in, we would have been working on a 25-year design life. But as you guys will be aware, with a number of the assets in Brazil, same with the North Sea and all over the globe, frankly, yeah, we're well beyond that, 40 years in some cases, and maybe even more. So once we get to this stage, they're not necessarily fit for purpose, and once we move into late life operations or trying to extend the life of the asset, we've really got to start implementing these as part of a well integrity management system, within the rest of the risk-based inspection programs. So typically, the conductor itself, as I say, I'm not going to read these 3D, but there's a number of different loads that, a number of different loads that'll impact onto the conductors themselves. It's not playing for me. I'm showing up images, but I'm sure you guys can imagine we get typically just above the guide frame, just above the LAT, the guide frame just below it, and right there on the water line. There's a number of different loadings happening there. Of course, we've got the operational loads where BOP landed or any kind of workovers, and even sometimes we're getting some kind of thermal expansion or some tensions within the pipe work itself. And I'm starting to see in a number of different areas a number of different corrosion issues also. You guys will have seen this type of stuff all the time, particularly from the well side. Majority of us will have a good idea as to what's going on with our annuli. If we've got communications, where's that communication going? How many barriers from the well are we seeing? And the conductors there to give that environmental protection from seawater hitting the surface casing, protecting the surface casing and the well load itself, taking the majority of the load of the well, and just protecting that casing integrity. And as I mentioned earlier, this went done as pretty heavy duty walled pipe, up 32 inches, and I've started to see bigger, as I've pointed out here in the wee bit on the side. That guide frame just above the water, we're looking at anything from +60, +20, and again, anything from -6 down to -20, 25. Places where the ROVs don't like going, places where the divers don't like going, and that kind of span and any connectors that we also might be seeing in between, where they're susceptible to that environmental loading also, and the build of the connector back in some cases the 70s when these things were run. And this is where it started for me. A client had contacted me when they'd started to see actually major gross damage appearing on the conductor down within that guide frame just below the waterline. I think it was -16 meters, maybe -12. And we started seeing holes being punched. And I can come on to the reasons as to why we were starting to see that. But as you guys will have seen, usually when we're going past conductors at that level and fairly shallow, we see really heavy marine growth. And if we're not getting in there, actually cleaning it away and having a look, then unfortunately we don't see any damage starting to move until we see gross damage or through wall damage, and starting to put at risk the integrity of the conductor itself, and that loading will start moving on to the surface casing, the rest of the tubing, or even here we're starting to see the connectors parting. This would have been covered up by marine growth again. So like the poor subsea inspection, or in most cases no inspection apart from an ROV or a diver, in some cases that shallow, happening to see it. Usually it's seen by accident, at which point it means that it's gross damage we're dealing with. And you can see here we've got gross damage down here from that different type of slamming movements we were getting, but again I'll come on to that. Main defect mechanisms, that fretting happening with the circular motion that we get with the conductor sitting within the guide frame, the dynamic loading from the conductor being crashed across under the guide frame, and of course that affects the guide frame and its own stability within the global structure. Of course, corrosion, as I mentioned, that we're starting to receiving, the static loading itself on the conductor through its everyday working life. As I mentioned, this kind of fretting, this was pretty early on. You can start to see that where it's eating away at the wall thickness of the conductor. Luckily enough, it was 1.5 inches thick, but we can already see the cracking that had started developing this conductor. Obviously, it was one that we'd ended up having to go through a P&A because of other issues within the well, and the economics stacking up. And again, that dynamic loading moving through, where we're pushing the conductor, where it's got the propensity to sit at the one side of the guide, and you guys will all seen this through offshore operations. So it takes that crash across and we get the hell of a noise. And when the weather picks up and through the depths of winter, and we start to get that cracking that appeared on the previous slide, slamming against that sudden stop. And where does that energy go? It actually, it's either going back under the conductor and starting to damage it, or it's going under the guide frame. Unfortunately, the same. We start getting that damage appearing under the guide. And much and such the same. You know, I'm not going to sit and read all this stuff, but you guys will have seen all this before. But we start taking the well integrity testing that we do as a matter of routine, and we start adding structural elements into it, and what's the risks that we're actually carrying for the well. And as I was starting to point out in that one of those previous slides, you know, we're starting to see this stress-induced cracking starting to appear. We've got, in some cases, low CP across the conductors and the conductor guide frame, particularly when that shallow area, we've lost it quite quickly. The ROVs and the divers don't like being there. The current inspections aren't monitoring or managing, as part of that risk-based inspection program, that type of corrosion rate or erosion rate, as we're seeing through the fretting. And actually what's happening, how's this affecting the rest of the well internally? As I mentioned, this was a big bit of dumb metal there to protect the clever piece being the well, but no one's been looking after it. So if it's not there to protect the well, where's the risks going to go on to, and what should we be doing about it? And as I mentioned earlier, this is actually the top slide or the top photograph on the right hand side and the bottom one are 18 months apart. We started getting measurements above the water. Unfortunately, in this place we had sea level drop by 1 meter and an increase in salinity of the sea itself by something like 3 times. And I caught the client doing UT wall thickness checks when you can see yourself that was pretty pointless. There's no point in measuring wall thickness when there is none. And yeah, this was happening over a 6 meter stretch, all above the water and right down below the water, wherever we started to see that movement to LAT. And as a lot of us have seen, I was just discussing it the other day, we've seen 2x4s, bits of wood, life jackets, whatever, when we can see movement of the conductors and no stabilization above the water, we'll stop it. We'll come up with better methods. We'll create wedges. We'll jam them down in. We'll try and arrest that movement or excessive movement of the conductor within the guide. But sometimes it ends up creating more of an issue. There'll be better examples than these photographs as I move on through the presentation, but you can see here a tieback conductor coming back into the platform. Usually we've got an oversized guide to the undersized tieback, and that means we get excessive fretting happening where it's actually just eating away, and we end up with a severed conductor, which brings about that loading now being transferred onto the surface casing and obviously the well. And these types of retrofit chocks can end up eating away at both the guide and obviously the conductor itself, causing localized damage. So I mentioned the connectors earlier. This is obviously typical pin and box where we see it, and when we see this above the water, you guys will, the majority of you guys will have seen it. We put on a fairly substantial moment clamp so we can protect this, because we're aware that the damage that's happening here is going to start impacting on the well, and it's going to start moving back again onto the surface casing and everything else. But what we're not seeing, so for the likes of this, we'll go and arrest it with a moment clamp. But if we're not cleaning and inspecting below the waterline, we won't look at this, we won't understand it, and we'll hope that it doesn't impact us, unfortunately, until it does. So once we've gone on, and this one was cleaned actually by an ROV at the time, and sometimes these connectors are difficult to find unless we can go and take measurements. But again, that flaring has already started on this connector. And actually, this was the same the next section of the one that I showed earlier that we P&A'd. So if anybody understands the pin and box of the connector, as you can see here, this would have had threads on it, where it would have been pushed together with the lower section. Those threads are completely gone to the point where it looks like it's been machined off. As I mentioned, we P&A'd this one because we got that excessive damage down through the guide, also heavy fretting, stress-induced cracking, and then we knew that this connector had gone also, and the well itself had no economics to suggest we should repair it. And this was actually the result that we started to get through the guide frame, where we were seeing that slam of motion, the cracking where it was going to start to spread, the through wall damage completely, and we knew this had already started developing down under the surface casing. A few more examples, obviously, as I mentioned, that stress-induced cracking being caused onto the conductor, as you can see here. Sometimes we'll fit a retrofit chock or whatever, and actually what it's done in this case is it caused the guide to split, which is then in turn got caught up within the guide and the conductor and punched a hole back into the conductor. This photograph was sent us by one of my clients, and yeah, the divers had got on, nice calm day, removed the Maringo so we could have a look and actually start seeing what's going on with not just this conductor, but what was happening in the rest of the field. Is back in probably 2015, to be honest. Yeah, but more. This was typically from fret, and you can see the step that's appeared on the conductor, where we would have had a centralizer ring go on to try and protect the conductor. We've smashed that up with a dynamic loading coming across that, smashing it against the guide frame. We've got this Z shape through wall damage starting to appear, and actually the cracking that started moving on round would have given us a 360 circumferential damage right the way around, causing it to completely part. And again, as I mentioned, unless we're getting in and looking down or looking up through the guides with an ROV, or now the new advances that we've been making over the last number of years, no one's going to see this until it's actually parted, and we know that we've got major damage that we now need to do something about. So again, having a nice look down. There's no marine growth down on here simply because it's been rubbing against this guide over the last 25 years or however long it might have been. So we've now got a nice step, a huge loss of wall thickness, and that's not going to last too much longer. So as I mentioned, we see this above the water. We'll typically try and do something about it. Unfortunately, sometimes we go and weld chocks on, or as mentioned, life jackets, 2x4s, wooden wedges, and other things, we'll go and do something to immediately arrest it. In a lot of cases, in a lot of the older assets, unless we start including it as part of a regular inspection, that leads to that's actually cement that's been getting knocked out of the conductor where it's been punctured. We can see the same again where something had been applied deeper down subsea, and it's punctured a hole right through the wall of the conductor. If that keeps up, this will puncture a hole right under the surface case, and also as it starts taking the environmental loadings. Sorry, some more. I'm sure a lot of you have seen these. Again, that chalk design, it actually had padding on this to try and protect it. It was wedged fairly tightly. But again, you can see the damage. We've already punctured holes here. If it's doing that above the water, what is it doing in the guide frame just below the water? I think this is the last one I've got to show again. More poor chalk designs where we've tried to do something and just allowed that damage to follow on. So I've mentioned the RBI being flawed is the best case, or actually not in place at all when it comes to conductors. It doesn't form part of the global structure, so the structural teams haven't typically been looking at it. It doesn't form part of the well integrity planning and management, so the wells team usually haven't been looking at it. And to be perfectly honest, from my experience from the well side, if someone started talking to me about bending moments and understanding it way back in the day, it's not something I would have wanted to get involved in. I would have handed it straight to a structural team and they would have had to take it on. So what are we inspecting? Are we inspecting it in the right places? Have we got the right equipment to go and look at it? And how often are we going and looking at particularly the wells that make the value case for the platforms that we're all managing, and working that through that economic system and ensuring that we're providing the best integrity system to manage this through to life extension, even as far as COP and decommissioning. Most of you will be aware of a number of these, obviously, so I'm not going to sit and read these. It's just the different bits and pieces. We can obviously go and do our own internal testing using the likes of DPEC and looking at cement levels and different bits and pieces. I've got very iffy results when it comes to it. When we're getting to this age of life of an asset, half the time the cement's gone or it's not providing anything sustainable between surface casing and conductor. Again, on the externals, then we're wanting to look at the conductor itself. I don't mean the typical wall thickness unless we're looking at heavy corrosion or corrosion concerns. At least understanding CP systems, any previous repairs we've had to do and why. Understanding what impact it might be having on the guides, any centralizers we may have installed and why did we install them, and are they actually still fit for purpose, or any retrofit shims that we've tried to put on, and any coating systems that we may needed to have put in place and has probably been forgotten about because it's not been included again in that integrity management. Again, as I say, I'm not going to sit and read these. We all do a lot when we see stuff. The well teams are well involved and understand regularly and pay very close attention to the annuals testing, well integrity testing, monitoring that, managing it and reporting on it. And we do a lot with it. The external bit is where a lot of it's been getting missed. However, if we see it above the waterline, it will very quickly get dealt with. Now, whether that's the right way to deal with it or the wrong way, it'll get taken care of. The rope access guys will get put onto place if that's what needed. When we're deeper down, I'm on about at minus 32, minus whatever below that. An ROV is comfortable being in place and we will regularly go. Also, there's less marine growth in a lot of cases. It's easier to see where we might have some issues. But this splash zone, just above, just below the water, places where rope access guys don't want to go down to, places where divers don't want to go up to, ROVs don't like being, it's getting completely missed, and it has been getting missed until we've started to see this damage, this gross damage. Again, I mentioned the likes of DPEC, checking cement levels, looking at fluid stack up, what are we maintaining in terms of levels. Again, in the air gap, we'll carry out wall thickness checks, we'll see it. We'll even carry out metrology and ovality checks and some of this stuff. Eddy current on this type of stuff is a maybe, but again, subsea deeper down will do it. It will do wall thickness, but as you'll see, the bits that has been getting better results for what we've been looking at recently is actually the ones that we'll be looking to try and implement, and we have been getting implemented with the majority of the operators that have started engaging on these types of issues and understanding the life expectancy and the life extension of their assets. Again, I've mentioned all these. I'm not going to sit and read them. And just giving people a chance to maybe understand their own cases and what should be getting done. Again, I've mentioned the ROV not really liking being above these depths. I know it's written on a number of contracts with the operators and the major service suppliers that they don't really like being above the -20, and it would take quite a bit of a push and commercial discussions to make them move beyond that, apart from it being a really flat calm day. So trying to maximize what we're trying to see. Steady video images let us understand what we're trying to look at and why we're trying to look at it. What can we do even just as a desktop review and study to understand what have we had in the past? Have we had issues? Has another asset similar close by had issues? You guys are part of a forum where you'll all discuss this stuff and talk about it. We should be sharing those ideas as an integrity forum. And then actually trying to quantify any type of damage or fretting, material loss, wall thickness loss, and what's the impact of that. And again, I'll not sit and read this stuff. There's a number of slides and a small animation to go with it explaining some of the approaches we've been taking. But even in some cases, some of the inspection contractors that we're working with haven't been reporting issues that we've seen. And as you guys all know, we'll see the same with caissons. The caisson will be in the seabed, despite us having an inspection contractor carrying out inspections and these things. So it's green on we're indicators and we're risk-based inspection program, but actually it's gone under the seabed. So it's actually it's had major issues. And this I've put up and shown it in a number of discussions. That's probably, and this is again down at -34, it's probably decent quality ROV image that we're going to get from an ROV trying to look at this stuff. What a lot of people miss from this is the likes of the anode bracelet sitting here, something that would get in the way if we're trying to go and even steady this. But there's no cleaning, inspection. This is just having a look and moving on by. And as a quick example, when I first started getting involved in this, I had a client contact me just before Christmas that they had now discovered the gross through-wall damage. By the time we'd gone through those discussions and carried out a desktop review, it very quickly became apparent that there was a number of other conductors at that -12 that had issues and should get looked at. We put an ROV out as we were preparing interventions, repair requirements, and remote requirements to discover another 6 further issues in the air gap with connectors. And again, then once we started working, cleaning, inspecting, managing this very old asset in the North Sea, admittedly, another 8 subsea connector anomalies had appeared, and we had to start discussing well value and economics and the right repair maintenance scenario. So what we do is, as a team, is trying to understand the implications of that damage, where we're seeing it. Are we seeing it at the guide? Are we seeing it at the connector? What's the right thing for this client? We're trying to measure the likes of material loss, particularly down through the guide where we don't want to put probes because the conductor's still moving, it'll smash. We want to analyze it. Me personally, I want to analyze it across the asset, and is one conductor more susceptible than another? Is one in the middle of a cluster as opposed to on the outer edge? If it's happening on one asset here, is it happening on another asset over there? And what are the differences? Is it the span between the guide frames? And again, as you can see with the flow diagram below, what we'll do through that analysis is, before we even go and inspect, we'll have worked out with the operator the levels of fretting that we'll allow for, that will look to arrest, or they'll look at the right type of repair for that asset, even for that well. And this all gets laid out on the mapping. So we take the well integrity data from the well integrity testing that's been getting done, and we map it with what we know in terms of guide damage, any failures we've seen through wall damage when we go and clean and inspect, and that leads to us having that through using that flow chart and previous discussions and decision support packages, that we know what the next steps are. There's no hidden secrets. All the costs are known, and the client, the operator themselves, can make a decision as to what's the right way forward in terms of this well itself and its value to the asset overall. Again, I'll not sit and read all of this, but there's more here than I can discuss, but a lot of stuff that we can already start doing in terms of the operator or even the major suppliers under the operators, and taking note of the likes of even wellhead drop stuff that's been getting lost, stuff where in terms of flow lines coming off it and what kind of impact any fatigue in that well is going to have on those flow lines and containment. And then again, just where's our connectors, marking it all up, managing this. In some cases, these wells were planted by at least 2, maybe even 3 operators ago, and now the new operator in charge has not got access to old designs. That well has gone through a completely different life, and there's information that's not been captured. So what we've got to do is go and restart building up that picture, so that in 10, 15 years time, when we come to decommissioning, there's a much better package, even that we've supported the well, we've let it reach the 15 years. And actually you can get a better decommissioning package and costs also from suppliers, because you know more information about what's being decommissioned. And this is where we get issues when we come in to try and do that analysis, is it's the majority of the time, and a number of operators we've spoken to haven't actually seen an issue, as in my conductors are fine, until they get through wall damage, and then it becomes an expensive repair as opposed to an inspection maintenance program, which the majority have been involved in, maintain, inspect. And we know that when it comes to repair, we've got to go and ask our boss for more money in terms of stealing someone else's budget. The well integrity, I've no doubt the majority of people have been taking care of that. And as I say, the structural stuff where the integrity responsibility usually sits in terms of the TAs has been getting missed in terms of the global structure, because it doesn't form part of that. And what reliable data points can we build up? What can we do as repeatable inspection that allows us to compare inspection now, inspection 5 years time, that we can go and we can actually measure and ensure that we reach a 20-year extension, a 10-year, 15, whatever the requirements might be, and actually go through in the individual well plans and hand it back to the economics team so they can decide what's valuable for the asset itself, and obviously then the organization itself. And some of my favorite stuff that we've been working on too. So you can see the typical parts that I've been pointing out, and a connector that we've got sitting around LAT, above, below, wherever that might be landing, the guide frame just above, the guide frame just below, where we're typically looking at wall thickness lost through fretting. We know the cement levels have been damaged. You've seen in the photograph earlier, it's turned to powder and is coming out. We know that we'll capture a lot of that by visually seeing it ourselves, and I'll come on to a few different repair maintenance pieces that we've got. We've seen the punctures. What can we do? We need to go and arrest it, as long as the asset itself's got value. Again, this will be available to everybody. This same stuff that's happening above the water is happening down here. It's still taking the same environmental loads, in some cases even worse, because it's starting to get impacted by potentially corrosion. This is one that I'm after, so we can go and try and attack some of the assets in terms of even carrying out an accelerometer, so we can measure the type of movement the conductor itself seeing. And measure that over time. We inspect now, we attach an accelerometer, we collect that data, inspect again in 3 years time, 4 years, whenever it works out, and we try and do that comparison so we can see that, so which ones are more susceptible. Can we apply it to other assets in the region? Is that information going to be repeatable? Is what value can we add to the industry in that part of the world, besides just carrying out repairs, wrapping, cladding? You know, you've seen a lot of these yourself. There's nothing here that's going to surprise anyone. Sometimes it'll provide structural strength. Unfortunately, when we provide cladding and wrapping, we don't know what's going on underneath, and it's very difficult to inspect without removing, particularly the likes of Manel further down the line. And obviously, if it's corrosion, then we're hoping it's not continued. We've got a number of cleaning and inspection techniques. So what we've done is design a C-clamp. It's now being used by the industry. What we're trying to look at is how can we best stabilize an inspection technique down through the splash zone. Keeping it simple, I come from a subsea background, as Pierre-Edouard mentioned earlier, and divers are very good at breaking stuff. And when the client asked us to start developing this remote tooling that would go down from rope access guys as opposed to hiring expensive ROV support vessels or diver support vessels, was what could we do with rope access guys to work above and below the water? And we came up with remote tooling that, again, the rope access guys couldn't break. And really, it's best described as a utility belt that allows us to go down, grab the conductor so we can be stable at the point we want to have a look around, and carry out full cleaning of marine growth. Use visuals, good visual inspection, and actually carry out laser metrology, UT, eddy current, the types of stuff that we've mentioned earlier, including guided wave where we can shoot that signal down the conductor that at least tells us if we may have an issue between connectors. And as mentioned also, there's a number of different repair techniques, maintenance techniques, everything from polyurethane poured solutions that we've done above. We've got bagged solutions that the industry's got very good at developing over the last 15 years and continues to improve. Ones that at this point we pass back to divers, but we've got solutions now that have been getting developed where this gets locked in and managed by, again, just above water remote tooling. The moment clamps that I spoke about earlier, trying to grab that issues with connectors that we've done in the air gap, and I'm sure a lot of you have seen these in your offshore life. We're now doing these below the water line across any connectors, provided that the wells get that value. Typical wear sleeves and 2 full shear support clamps that we would do above and below the water if we've got through wall damage. And again, when we're into that need for provision for moment, but it's actually going through the guide. And it's that need to try and look at remote installation. And you'll be happy to hear that's all my slides. I've just got the small animation that I'll pull up and just let people see how we're approaching this from the rope access point of view. So again, most people will be used to seeing, well, this isn't playing very well. There we go. Most people will be used to seeing this guide frame above the water. As this is pointing out, we're getting exactly the same. Some of the first issues we've dealt with is that fretting that's happening. So as I mentioned, simple cleaning and inspection tool, not very cleverly named, a marine growth removal tool. The rope access guys position it down onto the conductor. It drops under its own weight. There's no clever drive system or track system. It simply drops under its own weight. We've got our own sensors, etc., fitted to it. The C-clamp closes at the depths that we're wanting, and the lower section, as I mentioned, utility belt, carries all our inspection techniques, carries our jetting heads, typically barracudas, that we're providing HP water jet up to 1,000 bar. And that'll just step down the conductor until we've cleaned the sections that we want to clean. And in this case, like, allows us to step off, and we actually carried a laser metrology down through the guide frame so we can measure that material loss, as I mentioned, as opposed to trying to put probes down in there. We measure that material loss and decide, do we need to repair, do we need to arrest, or what do we need to do with this well? So again, there's a number of different repair scenarios. And again, this one is the dumb metal being similar to the conductor. It's there as an environmental protection. This one's a shear support clamp. The clever stuff that's been developed goes down onto that and allows us to do this in multiple different assets. It's never left subsea. So again, the rope access guys put this in place above the water. We can expand past anode bracelets. We can include it within the design. And again, allowing it to drop under its own weight. This simply drops down under the guide. So once we start getting down to depth, we've got cameras, torque sensors, everything included within that tooling. And it allows us to start stepping that down into the guide. As I say, we try to keep this as simple as possible because we're working in the splash zone, and it's not the nicest place environmentally for tooling, etc. to be. And it's as simple as that spigot allowing us to activate the preset torques, drawing that clamp together so the repair is now provided, putting that shear support back onto the conductor itself. All the clever stuff releases, and as I mentioned, we can bunny hop on the other conductors carrying out the same operation. And that'll be all from me. I don't know if there's any questions that people want to throw at me. I haven't seen in the chat yet as I've been working on the full screen.
Yep, there are some questions, Chris. Thanks for the presentation. We have one so far, which was asked about the difference between conductor jetting, drill and cemented, to the survival of the CPs in their marine environment. Have you seen any differences between, the various conductor that you have had to inspect in terms of survival?
Typically, when we're working on the ones we've been working on, the edges of them, it's been the old drilled, cemented conductors, battered back in the 70s. But I'll be completely honest, no, it's still that impact on the metal at the elevations that we're talking about. The connectors, in some cases, some are better than others, but I've not been seeing, again, in the 7-8 years I've been focusing and honing in on this area, I've not been seeing too much difference between a number of assets. Once we're actually on there inspecting, we're starting to see a repeat of the same damage being repeated, and the industry doesn't really talk about it because it's not part of an obligation to any of the integrity programs currently. So this is us trying to, we should be looking at this and protecting the assets.
Very good. Any image about or info about the life cycle of projects you've been involved in terms of, okay, we took so many months to plan a project, then inspect, and then apply some minor damage repair, and then follow-up inspections after that in the future?
Yeah, so what I've been trying to fit in, and because this is so new, sometimes getting a rope access team developed with tooling developed specific for the asset. I mean, the beauty of what a lot of you guys here in the Brazil side have is there can be a fairly uniform type of asset. A lot of them been built the same, similar type construction. So if it's happening on one, it's probably happening on another. But it also means that we can share resources in terms of equipment, experience, people, and manage that. Whereas when it comes back to the North Sea, all the operators were different, and everybody's got different sizes, different makeups, different spreads, different connectors, and they all come with their own individual issues that we've been trying to learn and build up the picture. So when we're coming to move into that, we can be something in the region of 4 to 6 months by the time we've developed the right inspection, we've done the onshore analysis, we've tried to understand what risks is the client potentially carrying. We look at the previous well integrity data. We even do some annulus top-ups to see if we're retaining water above a cement level. By the time we've got the tooling ready to go offshore, if I'm being honest, in the ones that I've worked on, a number of them have not been suitable to just simply take a wear sleeve. They've had to go and install an actual repair. It's few and far between that they're within the limits. But that's because we've been given a call because they've got gross through wall damage. And if it's happening on one, it's probably happening on another. It's pretty rare to be asked to come and do it just because a client and operator is starting to get ahead of themselves and understand there is a risk here that we need to go and look at, the unknown unknowns, as I've mentioned in the past. So that's the new bit for me, is getting involved with operators that are actually trying to get out ahead of this and go, let's go and have a look. Let's make sure this doesn't get the gross damage and impact the rest of the assets. So I'll hopefully I can update that in the next couple of years as to how regularly we should be doing it. I know when it comes to caissons, we're doing it 4 or 5 years. What should we be doing with conductors?
Okay, and I think you did capture quite an interesting specific point about Brazil, is that a lot of the projects were developed by a single operator, very often using the same procedure. So there will be more commonalities between platforms than elsewhere in some cases.
Yeah, absolutely. And,
So
and
I
the
have a
guys, have got to keep their tap dancing shoes on when they're understanding this. If we've gone and put chocks in place, um, are they right? Are they temporary? Have they become more permanent than temporary? Actually, are they there 3-4 years instead of ensuring we've done the right solution? Because if we're doing that at a plus 10, plus 15, then we should be looking at something at the minus 10, minus 15, or whatever that span might be, the 25 to 30 meter section.
Very good. So we have two questions on cleaning themselves. One is about, it's a question whether the cleaning affects the integrity potentially of the conductor. And then another related question is about, does it affect the corrosion rate of the connector?
So this is HP water jet. We're not using anything more substantial than that, although it does go up to 1,000 bar. Obviously, we don't go in and just switch on at 1,000 bar. We build ourselves up to that, ensure that we're getting a clean surface. If we want to land a structural clamp, we want to have a lot of that removed. They allow us to do a proper inspection. We want to make sure the majority of that's removed, depending on what type of inspection we're wanting to do. For the most case, the laser metrology is measuring where a lot of that's gone, but we've got to get down under the guide. It doesn't affect the integrity of the conductor. We'll be doing full onshore trials and a lot of this stuff. When we're offshore, we're in there, it's typically just removing marine growth. We're not removing metal. We're not looking at removing coatings in some cases, and that's if coatings have been applied. So corrosion rates, I showed the example earlier from overseas. I'll say the Caspian, where the sea level had dropped, and there was no point even cleaning some of those. It was removing the corrosion level. In some cases, that meant removing almost 6 meters worth of rotten metal, and that was a stabilization process and trying to work with the client to put a better solution in place than what they had, which was fairly thin conductors, as you can imagine.
Very good. One more question. It's actually related to subsea wells as opposed to platform wells. It's about, do you know anything? Have you inspected also structural elements, particularly the CP in subsea wells? Have you seen
So the
anything
likes,
there? Yeah, structural damage.
yeah, so the likes of a tieback, and some of the photographs there showed it, and I probably could have discussed them more. But when we're taking a tieback from a subsea well, when we've gone out with some of the older platforms, the guides were designed for the same the size of conductor that was going on, and the type of well design that we'd already agreed before the platform was on its way out to go on get installed. When it comes to a subsea tieback, we're usually working with much larger guides, and therefore the conductor getting pulled back through it or run back through it is substantially smaller. And what a lot of the time gets missed, particularly at those shallow levels, is the need to reduce that gap. I've worked with a client recently who'd done that. They had a 42-inch guide and a 30-inch conductor internal to it. And the conductor, although the wells, there was 4 wells, they'd only gone in 2 years. We're now 2 years already past their design life. So major impact on the connectors. The fatigue life of the conductor was already gone within 2 years, and with a major operation to go and arrest that and fix it.
Very good. And maybe a final question. And do you want to share some of your ideas about having to remove the sun coral, the coração in Brazil, and how that has affected the cleaning and the inspection itself?
So it was a curveball for me. I'll not lie. It was a new challenge. Obviously used to getting in there and blasting it away. So yeah, as you've seen, I get myself in trouble. We get asked questions by operators or a new problem that we've got to get around, and the answer is usually yes, and then we've got to go and figure out how we fix it. So as you'll have seen, we've got a fairly robust way of going and trying to tackle targeted cleaning and inspection on the specific areas of the conductor at specific depths. We've now got a coral collection basket that will fit onto our utility belt. MGRT, marine growth removal tool. And we've also got as simple as something to stop the tide taking it away, or the current taking that sun coral away, so that we can collect it as we're supposed to do now under these guidelines. And we've got a simple tarpaulin sack that'll now attach and fit around the marine growth removal tool. It'll be fully lit inside. We've got lights, cameras, everything to go with it, like the movies. And yeah, hopefully we've managed to head that off at the pass also, and it certainly looks like we have.
Very good. Okay, if there are no more questions, I had one just to get out of this specific topic you've covered of jetting, inspecting, etc. Have you ever been called for hurricane damage or specific, or boat damage? I mean, applying the same inspection to different types of damage using the same type of clamp, or for that usually they use divers?
So I've done different stuff with FPSOs and hull inspection requirements and what we've got going on there. Usually we're using a mix of existing technologies and trying to make sure that my rope access guys aren't breaking it. And it's figuring out the right way that we're applying those inspection techniques. I would love to get a call on for some of the hurricane stuff and see what they're dealing with, but no, it's not happened yet. So I'll remain hopeful, but we can apply a lot of this stuff. It's a case of keeping it robust and keeping it simple, because it's a splash zone, because it's under deck in a lot of cases, and it's shallow work. It's just making sure it works and we keep it easy.
Very good. All right. Well, Chris, thanks for the information. Good presentation on a topic which I think is particularly relevant to any mature province, including Brazil.
Appreciate it, Pierre-Edouard. Thank you, and thanks everyone.
Thank you very much, Chris and Pierre. It was a great opening for our SPE Tech Tuesdays, and I do appreciate you coming here and sharing your knowledge and your experience with all of us. Okay, thank you very much. So I'm going to switch to Portuguese now.
Thank you, Sergio. Obrigado.
Thank you. Pessoal, muito obrigado, né? Foi um evento muito bom, é nosso primeiro evento de 2023, tá? Eu queria agradecer a participação de todos, né, o tempo de vocês que estão aqui assistindo, aos nossos patrocinadores, né, que estão aparecendo aí na tela, e façam um lembrete aqui a todos que estão assistindo, né, que se afiliem ao SPE, né? O SPE traz uma série de vantagens para os profissionais da indústria, né, que não só a participação, né, desses eventos que a gente promove, mas também redes de contato, né, internacionais, onde se compartilha conhecimentos técnicos, né, conhecimentos de soft skills, né, e outros. Tá? Então, eu recomendo aí que vocês acessem o site www.spe.org, né, e se afiliem, né, o quanto antes, para começarem a ter acesso a todos esses benefícios. Tá bom, gente? Então, muito obrigado. Então, uma boa noite a todos. Mais uma vez, obrigado, Cris. Obrigado, Pierre. E a gente se vê aí na próxima Tech Tuesday. Valeu, gente.
See you. Thank you.